So this section is an intro to trigonometry. So we're starting with a right triangle, and then we're going to use trig functions to solve for certain sides. So when you have a right triangle, you pick an angle. It can't be the right angle, but another one. So I'm going to say let's pick this one. And this is called our angle of reference. And then we label our sides. So I like to start with the long one across from the right angle. That's called the hypotenuse. And then I go across from our reference angle, and that is the opposite side. Think if you're sitting opposite from someone, you're across from them. And then the last one is called the adjacent. So if you're sitting next to someone, you're adjacent to them. So I'm adjacent to the reference angle. Okay, and then we have these functions. So we have sine of theta, and theta is just an angle. This would be theta. And then we have cosine of the angle and tangent of the angle. And we just take a ratio of those sides. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We're just taking fraction values of these. Okay, and sometimes you see SOHCAHTOA. So S is for sine, and then OH. C is for cosine, and that's A over H. T is for tangent, and that's O over A. So SOHCAHTOA is a good way to help remember that. Alright, so let's get to the problem. We're given that cosine of theta is 11 over 19. Okay, now we have to remember, well, what's cosine? Cosine is the adjacent over the hypotenuse. So I'm going to use this triangle we already have here. This side, the adjacent side, would be 11, and the hypotenuse side would be 19. And we want to find tangent of theta. Well, tangent is opposite over adjacent. So we know the adjacent side's 11, but we don't know what the opposite side is. So we have to solve. And we're not going to use trig to solve, we're going to use the Pythagorean Theorem, because we know two sides of a right triangle. So if I use Pythagorean Theorem, a squared plus b squared equals c squared, c is always the hypotenuse, and then the other two, the order doesn't matter. So we'll do 11 squared plus b squared equals 19 squared, and I'm going to solve for b. I'm going to have 19 squared minus 11 squared is b squared. That's 240. But I don't want b squared, I just want b. So I'm going to take the square root of both sides. So b is the square root of 240, which is 15.49. But look at my answers here. There's no decimals, right? So I'm going to leave it as the square root of 240 for now. We're probably going to have to simplify that radical, just looking at my answers, right? Okay, so opposite is the square root of 240. So right now I have tangent as the square root of 240 over 11. But that's not here, right? So we're going to have to do what we said. We're going to have to simplify this radical. So to do that, we want factors of 240. I like to start with 2. 240 is 120 and 2. 120 is 60 and 2. 60 is 2 and 30. 30 is 2 and 15. Okay, so the square root of 240 is actually equal to 2 times 2 times 2 times 2 times 15. And then remember, we did this in quarter 1. This is really equal to the square root of 4. The square root of 4 is equal to 2. So when you have a pair of numbers under square root, they come out as just one number. Here's another. And why did I stop at 15? Because 15 is just 3 and 5, right? There's not a pair of numbers there. So you could do 3 and 5, but they're going to be stuck under the square root. So now on the outside, I have a 2 times 2. And then on the inside, I have a 3 times 5, which is 15. So 2 times 2 is 4, and then the square root of 15 stays. Alright, so instead of square root of 240, I have 4 square root of 15 divided by 11. And that's right here. That's my answer. Okay, so hopefully the next ones go a little quicker. We want to calculate sine of theta if A is 3 and C is 7. So first I'm going to start with, I know sine is the opposite side over the hypotenuse. So let's look. Theta is the reference angle. So here's my reference angle. Let's see what sides we have. I like to start with across from the right angle is the hypotenuse. Across from the reference angle is the opposite, and then the last side that's next to the angle is the adjacent. Alright, so I know the hypotenuse is 7. I don't know the opposite side. See? It's blank. So, what do we use? Pythagorean Theorem, right? I have to solve for that extra side. So C is always the hypotenuse. It's actually C on this. And then A is 3. So 3 squared plus B squared equals 7 squared. I'm going to minus this 3 squared on both sides. So I have B squared equals 7 squared minus 3 squared is 40. And then take the square root of both sides. So B is the square root of 40, which is a decimal. There's no decimals allowed here. I'm looking at our answers, no decimals. So we're going to simplify this. We're going to reduce it. So 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So instead of the square root of 40, I'm going to write 2 times 2 times 2 times 5. And remember, when we have a pair of something, they come out as 1. So I have 2 on the outside, that's this one. And then what's left inside is 2 times 5, which is 10. So the opposite is 2 square roots of 10, and then over 7 would be our answer. Right here, that's sine. Given that sine of theta is 3 over 8, calculate tangent. Okay, so sine is 3 over 8. Remember, sine is opposite over hypotenuse. So I'm going to draw a triangle. Doesn't matter, it just has to be a right triangle. Doesn't matter what side the angle's on. As long as you have a right triangle and you pick a reference angle of theta. Okay, now I'm going to label my sides. Across from that, the right angle is the hypotenuse. Across from my reference angle is the opposite. And then the side next to the angle is the adjacent. So I know the opposite of this triangle is equal to 3, and I know the hypotenuse of this triangle is equal to 8. I want to find tangent. Well, tangent is opposite over adjacent. So I only know the opposite side. I need to solve for the adjacent. So you see a pattern. How are we solving for the missing side? A squared plus B squared equals C squared. We're really using the Pythagorean Theorem. Okay, so hypotenuse is c, so 8 squared, and then the other side, it doesn't matter if it's a or b. I'll put it as b this time. Now we're going to solve for the missing side. So a squared equals 8 squared minus 3 squared is 55. So a equals the square root of 55, because we have to take the square root of both sides. So the square root of 55 is a decimal. And then if I want to reduce or simplify, it's 5 times 11. So I can't even take anything out because you have to have the same number twice. So adjacent is the square root of 55. Okay, so look over here at our answers. There's none of them are there, right? That's because you cannot have a square root in a denominator. Okay, that's not okay in math. So what we do to get rid of that is we do this thing called rationalize the denominator. And we did it in quarter 1, but let's do a quick review. We multiply by whatever's on the denominator, on the top and the bottom. So this is a fancy way of multiplying by 1. So on the top, these just come together. And then I'll show you what happens on the bottom. Square root of 55 times the square root of 55. Square root goes away, and we just get whatever's underneath. So that's our answer. We don't want a square root in the denominator. Alright, a word problem. A wheelchair access ramp has an angle of elevation of 32 degrees. If the ramp reaches to the top of a 35-inch high porch, how long is the ramp? So I'm going to draw this out so we can get a visual. So think about, we have a ramp. Here's the ground. Right, here's the ground. And then here, there's a porch right here that the ramp's going up to. Okay, so it's saying the angle of elevation, so that is this angle. It's 32 degrees. And it's going up to a 35-inch high porch. So this is 35 inches high. And it's asking how long is the ramp. So this. How long is the ramp all the way up to the porch? Okay, so we have a triangle. Here's our right angle. This is 35. The angle's 32, and we're trying to find x. So whenever you're dealing with a trig function, you want to label the triangle. What are the sides? Okay, so x is the hypotenuse. It's across from the right angle. Across from our reference angle is the opposite. And then the side next to the angle is the adjacent. And now we need to use a trig function. So what do we use? Sine, cosine, tangent. SOHCAHTOA are our options, and I'm gonna see what we've got here. So we are trying to find x, and we know the opposite. So which function has opposite and hypotenuse together? Sine. So sine of theta is opposite over hypotenuse. And now we're going to plug in everything we know. So theta is the angle. Opposite is 35. Hypotenuse is x. So what we just did is we created an equation that we have to solve. So we'll go through it this time. How do you get rid of a fraction? Do you remember? Multiply by the denominator. So what that does is these cancel and we get 35. And then over here, I have x times sine of 32. I want to get x by itself, so what's happening to x? It's being multiplied. So we're going to divide both sides by sine of 32. So x equals 35 divided by, look here in my function, sine, cosine, tangent, sine of 32, which is 66.05. There we go. So use the triangle to calculate the value for tangent of theta. So C is 23, A is 8, and here's theta. So we want tangent, which is opposite over adjacent. Well, let's label our sides and see what we have. Across from the right angle is the hypotenuse. Across from the reference angle is the opposite. And then the remaining side is the adjacent. So we know the adjacent is 8. We do not know the opposite. We gotta solve for it. So we're gonna use Pythagorean Theorem, where C is 23, that's the hypotenuse, A is 8, B is, I don't know. Let's find out. So minus 8 squared on both sides, b squared equals 23 squared minus 8 squared, which is 465. Square root both sides. So b is the square root of 465, which I think is a decimal. Yeah. I actually see our answer here too. So 465. I'm gonna see if we can reduce that though. Well, actually no. I'm just gonna stop because there's our answer. We're done. 465 over 8 for square root. Alright, got a couple more, just practice. These are different. Use the triangle shown to find the tangent of theta if A is 18 and C is 21. So we just did one just like this. Tangent is opposite over adjacent, right? We know, well, let's label our sides. Across from the right angle is the hypotenuse. Across from the reference angle is the opposite, and then adjacent is this last side. So we know the adjacent is 18, but we have to solve for the opposite. So when we solve, we use Pythagorean Theorem. We know C is the hypotenuse, and that's 21. And then the other ones can go in any order. So we're going to subtract 18 squared. So b squared equals 21 squared minus 18 squared is 117. Square root both sides. B equals the square root of 117 over 18. And I don't see any of these here. So I'm going to see if we can reduce 117. Okay. Or maybe we can just take the square root of 117, and we can't. Alright, so let's see if we can get anything that divides. So I'm going to start with 2. There we go. 3 times 39 is equal to 117, and then let's keep going. 39 divided by 3 is 13. So instead of 117, I'm going to write 3 times 3 times 13. And then when we have a pair of numbers, they come out as 1. So I have a 3 on the outside, and then this 13's left. Okay, so I'm going to rewrite this way down here. instead of the square root of 17, I have 3 square roots of 13 over 18. And then ignore the square root and just look at the numbers. 3 over 18 reduces, right? They both divide by 3. So I have 1/6. And then the square root of 13 is still there. I don't need the 1, so it's just square root of 13 over 6. Number 7, given that sine is 1 over 3, calculate tangent. So we have to know that sine is opposite over hypotenuse. So the opposite side is 1, the hypotenuse is 3. And to find tangent, we need the opposite over adjacent. So we know opposite's 1, we need to find the adjacent side. So I'm going to draw a triangle because it's easier to see what's going on. So we have a right triangle. Across from the right angle is the hypotenuse. And then just pick any of the other angles, it doesn't matter which one. I'll do this one. Here's the opposite side and here's the adjacent. So we know the opposite's 1 and the hypotenuse is 3. We need to use Pythagorean Theorem to figure out the remaining side. So we have 1 squared plus b squared equals 3 squared. If I subtract the 1 squared, I get b squared. 9 minus 1 is 8. Square root both sides. B is the square root of 8. The square root of 8 is a decimal, so we're going to simplify. Okay, so 8 is 2 times 4, 2 times 2. So instead of 8, I'm going to write 2 times 2 times 2. We can bring out a pair as 1. So we have 2 on the outside, and then this 2 is left on the inside. So 1 over 2 square roots of 2. Uh-oh, that's not there because you can't have a radical or square root in a denominator. So to get rid of it, we rationalize the denominator, meaning we multiply the bottom and the top by whatever the radical is. So on the top, 1 times the square root of 2 is the square root of 2. On the bottom, 2 square roots of 2 times the square root of 2 is 4. That's it. That's our answer. Okay, so these do have a lot of steps. That's why I'm doing so many examples. I'm going to do a couple more, but these are easy ones. It's just use your calculator. So cosine of 36. If you're in Desmos and you go to functions, cosine, and then you just type it in. Make sure you're in degree. Look what happens when you switch, okay? So cosine of 36 is 0.8090. Use your calculator to calculate tangent of 29. So tangent of 29, 0.5543. Okay, so those are easy. You just put them in the calculator.